A and KB, right? So have you ever wondered that why a strong acid has a has always has weak conjugate base, and a strong base has always it always has a weak conjugate acid? Like, what's the reason behind it? For example, we have a equation HCl decomposes into H positive ions and Cl negative, right? Cl negative, right? So over here the Cl, like we know that it's HCl is basically a strong acid, right? It's a strong acid, it is very strong, right? But this Cl, this Cl is obviously a conjugate base, and we have studied this in Bronsted-Lowry theory, right? So why the Cl is weak? What's the reason behind this? Okay, let's take another example, which is let's take ammonia. Like ammonia is a weak base, and when it basically reacts with water, it forms ammonium. It forms ammonium ion, right? And it forms what else it will form? It form OH negative ion, right? So over here, this, as we know, this ammonia is weak. This ammonia is weak, but this an ammonium, right? This NH4 is quite strong. This is strong. Like ammonia is a weak base, but the ammonium is a strong acid. What's the reason behind it? Always, or for example, if you have a weak base, and it will always produce a strong conjugate acid. Why? Like what does matter? Basically, these are conjugate acid base pair. They are conjugate acid base pair, right? For example, this is ammonium, right? If we react this ammonium with water, it will produce basically ammonia, right? And it will produce water. Basically, this is the this is just a reverse reaction. So here you can see this is ammonium is strong, right? This ammonium is strong, but this ammonia is weak, right? Like this ammonia is a strong acid, and it is producing a weak conjugate base. Like, what's the reason behind this? So today we will study about this reason. Okay, let's consider the Kc, like the equilibrium constant of, like, as you know, this ammonia is weak, right? And over here water is weak, so there will be obviously a equilibrium constant which will be Kc. So here Kc for the first reaction would be, what is Kc? Basically, this here it will not be Kc, it will be Kb, because ammonia is a base, and so for base, like for like Kc is what? It is equilibrium constant. So equilibrium constant for a particular base is known as Kb. So here we'll write Kb, and it will be equal to concentration of NH4 and concentration of OH, right? Over here we will write the concentration of ammonia, because water is constant, right? Water is constant, right? This water is constant, it will be like this. So it is the equation of Kb. Now let's write the equation for Ka. Ka, right? So Ka will be equal to let's try the concentration of ammonia over here. Ammonia, right? Right, concentration of ammonia, and here the concentration of water, because what is Kb? It is just like the product on as a numerator and reactant as a denominator. Over here you write ammonium, right? You write ammonium. Right over here. So basically when we'll multiply these both equations, we'll get like, if you multiply, this ammonia will be cut, will be cancelled. Over here this ammonia will also be cancelled. So what will basically left? So here Ka multiply by Kb is equal to, like if you multiply we'll get OH, and we will get this H2O, right? We will get this. So basically this OH and H2O, right? If you have studied the ionic product, or basically this is H3O, this is H3O, this is H3O, right? If you've studied the ionic product of water, you know that this is basically, this particular equation is equal to Kw, right? So over here it will be Ka multiplied by Kb is equal to Kw, right? So this is the equation which we'll get. Please underline this equation, this is quite important for you. Ka multiplied by Kb is equal to Kw. It's very very important equation for you guys. Okay, mark this in the red box. This is very important, right? Basically now it, according to this, Ka is equal to Kw upon, like it will be like this, Kb, and we know that Kw is basically a constant, right? Every temperature has its own Kw, like this Kw is temperature dependent. This Kw is temperature dependent, so obviously it is constant. It is constant for a particular temperature, right? It is constant for a particular temperature. We have studied this thing in my previous video too. So it means it is equal to, this equation is basically equal to Ka is equal to 1 upon Kb, right? So when we will reduce this is equal to sign, we will get a proportionality sign which will be Ka, right, inversely proportional to Kb, right? So it means that whenever there will be strong acid to the, like these both are Ka and Kb are both are inversely proportional to each other. So whenever, it means that whenever there the Ka value will be increased, the Ka value will be increased. Oh my god, what is this? When the Ka value will be increased, right? If the Ka value is increased, so the Kb value will be decreased, like the conjugate base value will be decreased. So that's the reason that Ka is inversely proportional to Kb. So that's why a strong, like always a strong acid will give weak conjugate base, and a weak conjugate, like weak base will always give a strong acid. So this is the reason behind this, right? So so this shows the conjugate of a acid of an acid is always a weak base, right? This shows this. So I hope this is clear to you. If you have any kind of query, you can ask me in the comment section. I'll be very glad to answer you guys, right?